Okay, welcome sa part 2 ng ating lecture on deflection using Macaulay Functions. This time, titingnan natin yung application ng Macaulay Functions into practice sample deflection problems natin. So, tingnan natin tong problem na to, no, una. A simply supported beam L with length L is loaded with the uniform distributed load starting from the left end and terminating at midspan. Assume that EI is constant all throughout the beam. Tanong sa atin una, what is the location in terms of L of the point of maximum deflection reckoned from the left support? And second, what is the magnitude of the maximum deflection in terms of the given parameters? So, first things first, no? I-draw muna natin, estimate natin yung magiging elastic curve niya, no? Kung paano ba magde-deflect yung beam natin. No? So, tentatively, gaganyan yung beam natin. No? So, ganun yung deflection ng beam natin. And yung deflection niyan, no? Ang maximum deflection niyan would be somewhere here, no? Malapit sa left support natin, no? So, yun yung kailangan nating hanapin. Ano yung value niyan? And saan siya nakalocate, no? So, gawin natin, calculate muna natin ano natin, no? Si reactions natin. So, let's say this is 0.1 and this is 0.2. So, we have R1 and R2. So, kakalculate natin yan. No? So, for R1, we will sum moments. No? O for R2 pala, we will sum moments along 1. About 1 equal to 0 yan. Let's set counterclockwise as positive. No? Palit tayo ng pen. So, moments about 1, isa-sum natin equal to 0. Let's set counterclockwise as positive. We have R2 times L minus W times L over 2 times L over 4, o kalahati ng L over 2, we have 0. So, R2L or R2 would be omega L over 8. Now, ito na yung ating R2. For R1, this is just simply summation of vertical forces equal to 0. No? Set as positive upward. So, we have R1 plus R2 minus omega times L over 2 equals 0. We have R1 equals 3 omega L over 8. So, meron na tayong reaction forces natin. Now, kung meron na tayong reaction, no, pwede na nating i-apply yung ating Macaulay functions, no, to get the moment. So, applying the Macaulay functions to get the moment, iset natin. Take note, tingnan natin yung arrangement natin, no, o yung placement ng loading natin. So, nakasagad siya to the left end, tapos titigil siya at midspan. Kung mag-reference tayo from the left to the right ng X, ang mangyayari dyan, no, hindi natin masasatisfy yung convention natin for the Macaulay functions, no? Kasi hindi siya nakasagad sa dulo. So, ang gagawin natin, magdadagdag tayo dito ng downward force para maisagad natin, tapos magka-counter tayo dito sa baba. So, effectively, dalawang terms yung moment natin, no? Due to the uniform load pa lang yun. So, ayaw natin yun, hassle yun. No? So, ang gawin natin, instead of the left side, mag-recon tayo to the right side, no? So, ganito yung x natin, no? So, hindi ito yung gagamitin natin, iyan, but this one, no? From right to left tayo. So, applying that, we have mx equals, una nating may encounter si R2, that's just omega L over 8. Upward, so positive, times x, no? Alisin na natin yung 0 kasi nasa 0 lang naman siya, no? So, that's just omega L over 8x. Then, i-trace natin si beam, no? Traversing. Then, pagdating natin at L over 2, dun papasok si omega natin, no? Si uniform load. So, dahil downward yan, minus W over 2 times x minus L over 2 quantity squared. Now, yung dulong reaction natin, di na natin i-consider yan dahil always negative naman ang x natin, no? With respect to this location. So, ito na yung ating moment function. That's just omega L over 8x minus omega over 2 times x minus L over 2 squared. So, apply na natin si DIM. So, kakalculate muna natin si slope, no? So, sulat natin yung differential equation natin equals m over EI. So, calculate natin si slope ngayon. Slope. So, ang slope natin would be, we have dy over dx. So, integrate natin ito, no? So, we have, multiply pala natin yung EI dito, no? So, dy over dx times EI, iangat na natin, no? Dahil constant lang naman si EI, i-assume natin, no? EI is constant. Dahil constant lang si EI, pwede na nating ilipat yan dito, no? Dy over dx times EI equals the integral ng ating moment function, omega L over 8 x minus omega over 2 x minus L over 2 squared dx. So that would be EI times dy over dx natin equals, we have omega L over 16 x squared minus, dahil ito ay 2, no? So, i-add natin yan, i-add natin ng 1, so that's 3. Tapos mag-a-add tayo, mag-multiply tayo dito ng 3. So, we have omega over 6 x minus L over 2 cube plus C1. So, meron tayong unknown na integrating constant, C1. No? So, tuloy lang natin, no? This time, punta naman tayo sa deflection. For the deflection natin, integrate natin a second time. So, we have y times EI, no? EIY equals integral nitong buo, no? So, integral of omega L over 16 x squared minus omega over 6 x minus L over 2 cube plus C1 dx. So, that's just EIY is omega L over 48 x cubed minus omega over 24 x minus L over 2 quantity to the fourth plus C1x plus C2. So now, meron na tayong deflection equations, no? Pero meron pa rin tayong unknown na constants, no? So, with that, a-applyan natin 'yan ang boundary conditions. So, ang boundary conditions natin, adjust lang natin yung canvas 'no. Boundary conditions natin would be at x equals 0 'no, at the right end, yung deflection niya should be 0 'no. So, kung titingnan natin 'yan, yung y natin 'no, kung 0 yung x, so this means 0 ito. Ito, 0 minus L over 2 is negative. So, 0 lang din ito. Then yung C1x natin 0 din. So, we're left with C2. C2 natin should be equal to 0. So, ganun lang kasimple yon. Now, tingnan natin yung second boundary natin, no? Second boundary condition. So, at x equals L, dun sa dulo, 0 din dapat yung deflection dahil may support tayo dun. So, x equals L, y equals 0. So, gawin natin, plug in natin yan doon sa ating deflection equation. So, that would be, we have omega L over 48 x or L times or L cube minus omega over 24 times L minus L over 2 raised to the fourth power plus C1L. Yung C2 natin, 0 na yan. No? So, hindi na natin isusulat yan. So, that's just equal to 0. No? So, solving for C1, ang lalabas na C1 natin would be 7 omega L, negative 7 omega L so, ang lalabas na C1 natin dyan would be negative 7 omega L cube over 384. So, ito na yung ating C1. So, kung meron na tayong C1, meron na rin tayong C2, pwede na nating i-apply yan, no? Doon sa ating deflection calculations. No? Or sa ating deflection equation tsaka sa slope equation natin. No? So, applying, we have, malipat lang natin, we have slope natin, no? That's EI, theta na lang yung gamitin natin, equals omega L over 16 x squared minus omega over 6 x minus L over 2 cube plus or minus 7 omega L cube over 384. And yung deflection natin, no, would be EIY of x equals omega L over 48 x to the fourth or x cubed minus omega over 24 x minus L over 2 to the fourth minus 7 omega L cubed over 384 x. So, eto na yung ating deflection and slope equations. So, solving part 1, what is the location in terms of L of the point of maximum deflection from the left support, no? So, ano daw yung maximum deflection natin? So, balik tayo dito sa figure. Maximum deflection ang hinahanap natin. So, ito. So, take note, kapag nag-draw tayo ng tangent line along the point of maximum deflection, yung tangent line natin, horizontal lang yan. So kung horizontal yan, ang slope niyan should be 0. Okay? So ibig sabihin, at the maximum deflection, 0 si slope natin, no? 0 si theta. So balik tayo dito, no? So at max deflection, theta equals 0. So ang gawin natin, itong equation na to, i-equate lang natin siya sa 0. So 0 equals, now tingnan uli natin yung figure. Ang assumption natin ng maximum deflection, no, is lampas siya sa L over 2. So take note natin yan. Now we have 0 equals omega L over 16 x squared minus, since yung assumption natin ng maximum deflection natin is lampas siya ng L over 2, no? Lampas ng midspan. So ibig sabihin itong term na ito, no? This is always positive, no? So yun, pwede na nating i-kopya na lang, no? Kopyahin na lang natin yung loob and change it to normal parenthesis na lang, no? Hindi na natin gagawing Macaulay brackets dahil lagi naman siyang positive. So, yan. Or cube pala ito. This is 6 omega over 6 times x minus L over 2 cube minus 7 omega L cube over 384. Now, cancel natin si omega, no? Now we have L, no? So, para mabilis natin i-solve, ililet natin, let L equals 1, no? Para mabilis. So, solving natin, no? Using L equals 1, we're left with 0 equals x squared over 16 minus x minus L over 2 cube. Tapos may 1/6 tayo dito sa labas. Minus 7 over 384. Solving this, you have x is approximately equal to 0.56 L. Now, titingnan natin yung figure, no? Ang tanong, reckoned from the left support. Pero ang origin natin, right support, no? So, gawin natin, ibawas lang natin sa L yan, no? So, that's just D. Let's say D yun, no? So, L minus 0.56 L. So, ang distance natin from the left support would be 0. This is 54 pala. This is 54 L. No, so, babawas natin yan sa L. That's just 0.46 L. So, ito na yung ating sagot for item number 1. So, ito na yun. Now, for item 2, hahanapin natin yung maximum deflection, no? So, that's just substitution, no? Substitute natin itong 0.54 L natin sa Y. So, we have EI times Y equals omega L over 48 times 0.54 L quantity cube minus omega over 24 times 0.54 L minus L over 2 raised to 4 minus 7 omega L cube over 384 times 0.54 L. Solving this, we have 0.eiy equal to 0.006563 omega L to the fourth. So finally, y natin is just the quotient, no? Ibababa lang natin si EI. So we have 0.006563 omega L to the fourth over EI. Oh, so ito na yung sagot natin for item 2. So ganun lang kadali i-apply yung ating yung ating Macaulay function, no, sa double integration in calculating deflections natin. So that ends yung solution natin for problem 1.